In today, we will discuss in the topics of satellite and their all derivations, the derivations of orbital speed, kinetic energy, potential energy, and height of satellite, and all other derivations that will be related to satellite. What is satellite? In gravitation chapter, satellite has a very important role, and all the derivations of the satellite related to satellite is very important role. So what is satellite? Satellite is a object which moves around the planet, which moves around the planet. You know, in solar system, there are so many planets, and few planets have a satellite and few planets don't have satellite. Earth have a satellite. Earth has its natural satellite, that is the moon. Moon is that satellite which moves around the earth continuously. It is natural. But in electronic revolution or scientific revolution, there are so many artificial man-made satellites are also thrown, or you can say settle in a certain orbit by a scientist, and that satellite is used for our development purpose. We use for a particular purpose. As you have heard so many name of the satellite like Aryabhatta, Inset, Apple. There is so many version of Inset, IRS, Rohini. These are the name of satellite. These are those satellite which moves around the earth. It is artificial. Some satellites have a certain, they work for the certain time period. We use that satellite to do electronic communication. We use satellite for the working of the TV channels, FM broadcasting service, TV broadcasting service. Sometimes we satellite use for the security purpose. And some satellites are also used by NASA. In present day, we use GPS system, global positioning. This global positioning system is monitored by 24 satellite that is installed, 24 satellite installed by NASA around the earth. Whenever we find the position or location of any devices through GPS, so GPS, at least 3 satellite monitor that GPS location. So we can find out every angle position of particular position of particular device, because they are monitored by total 24 satellite working around the earth to find out position of anything. But to find out everything means height, depth, its exact position, 3 satellite is working or monitored by that, monitored by 3 satellites, at least 3 satellite to that object. But we don't have to go further about the how positional and what is the details of satellite that is used in GPS. But presently, we will do about the satellite, that simply how satellite works. As you know, there are a gravitation force between two any object, because we are discussing about the, we are mentioning here about the satellite that moves around the earth. So there is a gravitation force between satellite and earth, and because satellite moves in a certain orbit, that is the circular orbit, it moves on a circular orbit, that is the around the earth. So there is some centripetal force, or you can say centrifugal force that act on the satellite. So here gravitational force and centrifugal force is balanced. So that makes balance to moving continuously, satellite continuously throughout the earth. It happens as well as natural satellite and as well as for the artificial satellite, because natural satellite is already fixed during formation of stars or solar system. So we do not change, and their alignment are completely fixed, final. It is at equilibrium position. But the satellite we installed in space, so our scientists have done very effort to settle satellite to in particular position that works properly for longer time. So they have done so many experiments. The main things about the satellite is only gravitational force between satellite and Earth is balanced by centrifugal force. You know the formula for gravitational force, it is the G m1 m2 upon r square, where m1 m2 is the mass of object. In this case, one mass will be mass of Earth and another mass will be mass of satellite, and r is the distance between center of Earth to center of satellite. Because satellite exists or stays on a certain height, so obviously distance between center of Earth and center of satellite will be larger than radius of Earth. For our convenience, we will take height of satellite from the surface of Earth is h, and r is the distance on the surface of Earth from center to surface of Earth. So total distance from center of Earth to center of satellite will be r plus h. And you already know the mass. Mass one is m1, on another one is m2. But now, if m is small m, take a small m is the mass of satellite, and v is the speed with which it moves around the satellite, making equilibrium position. So its centrifugal force will be mv square upon r, or mr omega square. So though whatever the steps that we are telling right now, I will do with written in next page. In next page, I have made a gray color solid sphere. Consider this is the Earth. This is Earth, and r is the radius of Earth. A is the point on surface of Earth, and B is the another point where satellite actually exists. Actually, it is not exactly on the B point. It will be anywhere, but the I am making a small spherical black object at B, that is the satellite. So this moves with certain velocity. Take the velocity of satellite is as a v, and its height from the surface of Earth is h. Here, this is the Earth, and this is satellite. Now, gravitation force is equal to centripetal force. So gravitational force, we are taking for our convenience mass of Earth is NE, and instead of radius, we are taking is RE, E for Earth. So gravitational force will be G ME into a small m. A small m is the mass of satellite upon distance is r plus h square. R plus h square is equal to mv square by r. mv square by r. Actually, it is r plus h. R plus h. Now, make some terms. M cancel. Height cancel. So it will be G ME upon R plus H equal to V square. V square. Here V is the speed with which satellite moves around the Earth. So V is considered as a orbital velocity. So V equal to root under G ME upon R plus H square, R plus H square. Sorry, there should not be a square here. So this is the orbital velocity. orbital speed. We can, it is not good to say velocity because velocity have a direction. So it is orbital speed. In question, if it is asked what is the orbital speed, then you will say orbital speed is the speed of satellite with which it moves around the Earth on a certain height. You can define orbital speed is the speed with which orbital speed is the speed with which satellite moves is the speed with which satellite moves around the Earth in certain height. Orbital speed is VO, that is equal to GME upon R plus H. Now, orbital speed is VO equal to GM upon R plus H, you know. But we know acceleration due to gravity is small g equal to GME upon RE square. So after cross multiply, we get GM equal to GR square. From this, we can change orbital speed. We will put GM as GR square. So orbital speed will be VO equal to GR square upon R plus H. Upon R plus H. You can use this both formula for orbital speed as it required. Now we are finding the time period of satellite. You know the time period, time is equal to distance upon speed. So it is distance is circumference upon speed. So I have taken circumference as a 2 pi r upon VO. But in orbit, the circumference has a radius. Exactly its radius is RE plus H. So we can write a small r, that is the distance from center of Earth to satellite. It is r, a small r equal to R plus H. So we will put this value here and we got the time period. This time period is the time taken by satellite to move once around the Earth in a given orbit, in a certain orbit. Two pi r e plus h upon VO. So put this value of VO, orbital speed. It is g r e square by r plus h. This will be equal to 2 pi the root under RE plus H to the power whole cube divided by GR square. This is equal to time period. Time period is the time taken. This. Now, you can also find out using this formula the height of satellite. Height of satellite. Height of satellite. So T equal to 2 pi root under RE plus H cube upon GR square, making a square in both sides. At implies T square equal to 4 pi square into RE plus H whole square divided by GR square. It implies it is R height cube. So R plus H cube equal to, it will be equal to T square GR square upon 4 pi cube. Not 4 pi cube, it is 4 pi square. Because one side it is a R plus H cube, so we have to make a cube root in both sides. So after that we get R plus H equal to T square gr square upon 4 pi square to the power 1 by 3. I will write this in next page. So r plus h equal to T square gr square upon 4 pi square to the power 1 by 3. This implies height of satellite h equal to T square gr square upon 4 pi square, it is really power 1 by 3. So it is power of 1 by 3 and minus h, minus r not h. This will be formula for height of satellite. It is easy. Height of satellite. Now we have to find out kinetic energy and potential energy of the satellite. Ke, kinetic energy of satellite. You know formula for kinetic energy, we simply know it is half mv square. And what is the formula for potential energy between two objects? When we talk about the potential energy is Pe. So potential energy formula for potential energy in gravitation, it is G m1 m2 upon r. So this is formula for potential energy. It is negative, where m1 m2 is the mass of two objects and r is separation between them. So in this case, potential energy, first I am finding kinetic energy, then potential energy. So you know the formula for it is m, it is centripetal force equal to gravitational force. So centripetal force is m. You can take m1, small m. I have taken a small m. M v square upon r e plus h equal to g m e m by r plus h whole square. But here this will be cancelled and we divide this whole by 2, that becomes half mv square. So kinetic energy will be Ke, kinetic energy of satellite will be equal to half mv square equal to g me m by re plus h. This is kinetic energy, and potential energy of satellite is equal to minus g me m by r plus h, re plus h exactly. So what is total energy of satellite? So total energy of satellite Te equal to g me m by 2 re plus h minus gme m by re plus h. Right, all these things. So final, here we get a final energy. It is a minus g me, that is mass of earth, m mass of satellite, upon 2 re plus h. This is the total energy of satellite. Write down it.